Okay. Raise your hand if you've started assignment 3. Raise your hand if you're done assignment 3. No. One person? Hey, 2? Hey, that's pretty good. How about this? I think I want to extend the deadline to next Monday. Is that? Are you? Oh, thank you. I'm glad you're so very easily impressed. So for those of you that are already done, well done. That's awesome. But for the sake of, look, I know this is a messed up year. It's a messed up year for you. It's a messed up year for me. And I know, usually in undergraduate degrees, what I like to say, it's like an exercise in damage control. You're just going from putting out one fire to another. And this year, it's that much worse. So I understand. So I'll give you a little bit more time for assignment 3. Know that assignment 3, it's a tricky one. And also know that that one question, print board, is supposed, if you're thinking, oh, this should be easy. No, that's actually supposed to be the hard one. So, or one of the hard ones. So do take your time with that. On a more mean note, I suppose, do I have it here? I do. So I started making the final exam. I mean, I've only just started, so right here I've got a list of do's and don'ts. And on your final exam, I have no control over what you're doing when you're at home doing your final exam. Also, don't ask me when it'll be due. I actually don't schedule that. It's done by the registrar. But I will tell you, as soon as I can release it to you, I will release it to you. So you'll have it for however long. The final exam, I actually really take pride with how good I am at writing exams. Although I admit I've never done one that's a take-home one. My exams tend to be really, really, really good at picking out who gets it and who doesn't. Usually those that don't have an understanding get close to 0, and those that get it get close to perfect. And there's not much in between. Also in computer science, it's not atypical to get a bimodal distribution on tests. So you might be familiar, oh, you get that bell curve on tests. Well, in computer science, it's actually very typical to get kind of 2 bell curves, by the way. And the goal is, for me, is I actually want those 2 curves to be as far away from each other as possible. Because I want the tests to reflect your understanding. Anyways, because I don't really have any control over what you do when you're doing the test, I've got a couple list of do's and don'ts that you gotta follow. But if, you can use Google, I don't care. You can use the lecture content, you can use your notes, you can use the YouTube videos. But you may not work with one another. You may not receive help from anyone. If you know someone who's a programmer, don't ask them. You may not copy-paste answers from anywhere, any source, whatever, if they exist, if you can find it. And the beefier questions on this exam, you're not going to find solutions to them online. But here's the deal. Because there's effectively no way for me to guarantee you're not going to cheat. And one of my great joys in life is catching cheaters. What I'm going to do is, if I see a solution on an exam that is very impressive, but I suspect, you didn't write this. If there's any inkling of, I don't think you wrote this, I will start an investigation. And that investigation will include me and the chair of computer science. And we're going to have a meeting with you, and we're going to ask you to explain your code. If you could tell me what this does clearly such that you satisfy us that, clearly you know what you're doing, no problem. Easy peasy. But if you start explaining and it becomes abundantly clear, oh yeah, you have no idea what you're talking about, you don't even know what a function is type thing, we're going to give you 0 on the exam and submit it for academic misconduct and let the university decide what they want to do with you for having cheated on an exam. Long story short, don't cheat. But if you do, I will have fun finding you as a cheater. Any questions about that? You want to see it real quick? Wait, no, I better not, because you might be able to pause it. Usually what I do is I blitz through it and be like, oh, there's the whole exam, but I can't do it because maybe you can pause it on YouTube. I don't want to do that. It's not done. I've still got to make a lot of extra questions in there. It's not very long at this stage. But I like this exam. I think it's a good one so far. Any questions about that? Yes?
How long will it be, like, once you're done adding all the questions?
I have no idea. Usually I tend to get carried away and then I go, okay, I gotta cut some of these.
Okay.
So, I don't know. Realistically, I probably just, one sec. I probably want it to be like, well, if this was a regular exam, I want it to be like, if it was a regular exam, the exam would be like 3 hours or something, right?
Okay.
But that doesn't mean you necessarily need the 3 hours, but that's kind of like, well, you've got 3 hours. So I've got that in mind for like length. But of course, like, because you can use whatever material you want, like Google, and you can test your code, the exam's going to be a little trickier than previous years because, you've got all those extra resources. But that's a good thing, right? Because if you understand it, you can use those resources, fantastic. That's what I like. You're a good programmer. Yes?
How do you expect the difficulty to compare to assignments?
Definitely less difficult than assignments, but that's, of course, entirely subjective to me and everybody else. But it's not designed to be near the difficulty level of assignments. Like, questions would be like, I'm trying to think of an example. Pardon?
Show us one.
No. But I'll give you an example of something that, like, might be there. Like, you know how, like, on assignment 3, you have to print out the board, right? No, that's a bad example, because that might be hard. Assignment 2, you had to do like one of the bits of assignment 2 is do a linear search. So maybe it's like do a linear search or something, You had a question.
Yeah, if I know one of the ones that I already asked, but when the exam like opens up, do we have like 3 hours to do it?
No. It opens up and then you have to just submit it before the day that the registrar says it's got to be done by. And also what I'm going to do is for all the questions that I can, like write code to test, like I will include which tests like in there, because it's just going to be like on Colab. So it'll be like, okay, insert code here type thing. But then below I'll call like a function and be like, okay, with these parameters, those parameters to test it. So that way you'll immediately know, like, is it doing what it's supposed to? And I will be using those for testing purposes to kind of automate it. I saw a hand up there first. You had a question?
Oh, I was going to ask if they were more like akin to Canis or the lab.
Probably closer to the lab, but again, subjective, and I'm not done making it, and I want plausible deniability. Yeah?
Do we have to use the lab? Or does that really...
You have to use Colab?
Do we have to?
No, because in the end, I want you to submit your Python files. Do I? Yeah, maybe you, definitely use Colab actually. So I know you like not Colab, but just make it work. Any last questions? Okay. Cool. Okay. We were talking about dictionaries, and dictionaries are amazing. Did anyone figure out how to do that two-sum problem a better way? No, that's okay. I was just curious. Okay, now I'm going to talk about sets. I'm going to show you sets. They may or may not come up in like assignment 4 and whatnot, but understand that the amount of understanding of sets can be relatively superficial. Raise your hand if you're familiar with sets as a mathematical idea. Long story short, I'm asking you, did you pass grade 10 math? Okay, you actually already know sets, but I'm going to go over them again anyway. Here's how to create a set. Great. Print A, we get something like that. So I'm saying create a set, we're starting it as empty in that first example, and then it says, oh, here's a set, there's nothing. And if I ask the type, Python knows, oh, this is a set. Great. And I might also say, okay, here's a set, but I give it like the list 1, 2, 3, 4. Well, then it creates a set 1, 2, 3, 4. So a set seems to be another one of those linear data structures. It kind of looks like a NumPy array. It kind of looks like a list. It kind of looks like a tuple. What's the difference? Well, if you remember back in math, when you have a set, one of the rules are you can only have one copy of each thing in that set. So, in this example, I've given it 2 2s and 4 5s, but in the end, it only gives me 1 2 and 1 5. Because the rules with sets are you can only have one copy of each thing. Another noteworthy thing to say that is kind of true in Python, but also kind of not when it comes to sets, is technically sets are supposed to be not ordered. So there's no intrinsic ordering to the things within a set. It's kind of just like a bag of things. So if I pull something out, it should just be some arbitrary value. With a set, I can ask something like, oh, I can use that in on the set, which is pretty cool. Is 3 in C, where C is the set? True. Is A? No, it's not. It's false. We can also do a linear search with a set very easily, because I mean that in operator is kind of doing the linear search for us, just like with lists and everything else. So, look here, if I say 4th thing in C, it's going to print out 1, 2, 3, 4, 5. Now you might say, well, hold on, clearly the order mattered there. Yeah, but technically it doesn't. But it just so happened that they came out in the right order. So if I'm doing 4th thing in C, that's going to be for each element in the set C. I print out, ooh, there's a huge typo there. Who sees it? I got to fix that. No one sees it? What do you see?
You're supposed to print thing, not C.
Yeah, I'm supposed to print thing, not C. If I actually ran that code, it would print out the whole set 5 times. Well, let me show you what I mean. This is what it's supposed to be. But this is what I wrote. So that was a typo. I'll fix this later. This should say thing. Because I'm printing out the whole collection for each thing in the collection, which is kind of weird. So that should have been C. Anyways. If we can iterate over the things in the set, we could simply do that linear search like we did the linear search with every other linear collection. Is thing the thing I'm looking for? Is the next thing what I'm looking for? Is the next thing the one I'm looking for? And so on as we go through that loop. I can add things to set. Add. If I try to add hello again though, well, it just ignores me. It's like, okay, but it doesn't do anything because it's already there. I can remove things, discard. If I try to discard something that's not there, it just kind of ignores me, which is neat. But there's also something very similar. There's something called remove. If I remove 5, it removes 5 just like discard. But if I use remove, when the thing isn't actually in there, so I removed 5, great. So now the set is 1, 2, 3, 4. If I try to remove 5 again, it's going to say, whoa, there is no, that's not a thing. So that's the difference between remove and discard. You're probably not going to memorize this. You're not going to remember this, and that's fine. Because if and when you're using sets, you'll go, oh, right, which one do I need? And then you test them, and then you'll find out very quickly. Yes?
So what would be the advantage of remove over and discard?
If, for example, I'm really damn sure that this thing is supposed to be in that set. It's supposed to be, and I have to remove it now. And I say remove, and then it says, oh, it's not in there. I got a big problem. So it's a way of kind of checking like validity and if things are actually there and whatnot. Maybe it doesn't really matter, maybe it really matters. And if that's not in there, the nuclear fuel rod's going to explode on our spaceship. I don't know. A lot of these things, like you're really right. A lot of these things won't make sense until they make sense. And I know that sounds like a ridiculous statement, but sometimes until you get familiar enough with them, you go, oh, that's the point. That happens a lot in computer science, and it goes back to what I was saying a couple of, like 2 months ago, where there's no order. I mean, there is kind of an order on how you teach things in computer science, but once you get deep enough, sometimes you run into the problem of like, well, here's how this works, but it won't make sense of why it works until we learn this, but we can't learn that until we learn this and this. So it starts to become a bit of a web. Because remember, for better or worse, Python wasn't made by people for you to learn how to program. It's great for learning, but it was made by like software engineers for software engineers because they knew what they wanted to do. So sometimes the motivation for ideas won't be clear until just a little bit later. And that'll happen a little bit more next semester, but it's not too bad. We can clear a set. We can actually check if sets are equal, which is pretty cool. Remember, order doesn't matter. So 1, 2, 3 in the set 3, 2, 1, they are the same. So what else is cool about them other than just uniqueness and orderlessness? Well, they might not seem overly special. Sometimes it's great. Sometimes we really do want some sort of collection that'll only keep track of one version of each thing. Okay, cool. But they're very special. Sets. So remember how I said in? Like we'd say, oh, is this in that? And it says true or false. And it's like doing a linear search. Well, technically, it's not. Because sets are built in the back end as dictionaries. So a dictionary, remember, it's a key value pair. Basically, the set is basically a dictionary. So let's think about these equivalencies for a second. And this, by the way, thinking of how things are actually equivalent in computer science is a really big thing. We do this a lot. So, the idea of a set. Well, what if I just make a dictionary where the value I want to put in the set is the key? But wait, let me reword that because I don't want to confuse the value and the value. The thing I want to put into the set, like the number 5, I will make that the key to the dictionary. The value in the dictionary doesn't really matter. So the value at key thing, maybe it's true, it exists. Then, if I want to check if something's in that set, I just check, can I access that key? Is it there? If it's not there, it's not in the set. If it is, it's there. So suddenly it becomes a really quick lookup. If I tried to add something with the same key, it knows, well, just don't. That key's already in there, we're fine. Really good. So sets are actually based on dictionaries, which are really cool, depending on the implementation. But we can see how we can make them like equivalent, or how we can make a dictionary act like a set. I should say that. Because a set can't be a dictionary, but a dictionary can be turned into like a set. So make sure you understand what I just said there, because before I kind of lied. I said, oh, they're equivalent. Well, we can make one equivalent to the other, but not the other way around. So in is actually going to be a little quicker with sets than other linear collections. Here's what I want you to do. This activity, I'll give you a couple minutes. Load this up into Python. And see if you can answer these questions. Is there any easy way to determine if set A is a subset of set B or whatnot? And all these other set operations. And if you're trying to remember what these things are, these are like the set operations and what they mean mathematically. If we ask for the union of A and B, well, that's going to take everything from A and everything from B. Great. If there's any overlap, whatever, it doesn't matter. The intersection is, what's in both. The difference between A and B, okay, the difference ignore for a second. But then also a subset, that's asking is everything in A also in B? So try to answer these questions. See if you can figure out in Python how to do it. I'll give you a big hint. Don't start writing your own functions. See if certain methods exist or something. Just play around for a couple minutes. This was what I meant by the hint at the bottom if you didn't know. Type it and then dot and then hit tab and see what you get. Let's see. So I have set A, and I wanted to know if set A is a subset of set B. Well, dot. And I see something here that seems rather promising. So this subset, and let's see. Report whether another set contains this set. All right, well, let's see. Let's see if set B is a subset of set A. False. Okay. So here. Let's print out both. Well, look at that. I'm asking, is set A a subset of set B? Do all the things in A exist in B? True or false? Yell it. Ooh, it's Friday, I know, but the day's not over. True, of course. 0 and 1 are in the set B because set B has 0, 1, and 2. But then the question, set B, is it a subset of set A? Do all the contents of set B exist in set A? Yell it. False, of course, because, I mean, it's missing. What else was it asking? The union of two sets. All right, well, I guess that's rather not interesting, because if A is a subset of set B, the union of it is just going to be, the bigger set. So maybe we should try a more interesting one. Set C. Whoa. Oh, there we go. So it's the union. It threw the C. It threw the 3 from C in it. Great. What if we do intersection? Well, look at that. That asks, what's in both? Well, the only thing in both is 2. And it's telling us right there. Difference, that's a fancy way of saying what's in, the difference between A and B is what's in A, but not in B. Or reverse. This one's a weird one. People sometimes are getting stuck on it. Don't worry, that question won't be on the exam. I'm just showing it to you just in case you care. So what's in set B dot difference? So what's in B but not in A? Well, that should probably just be the 2, right? Yeah. Because what's in here that's not in there? Well, only the 2. Cool. Anyways. So again, you might be saying, okay, great. All right, so it's a fancy mathematical object that we can use in Python. Yeah, but it might have some really good practical uses. Because imagine, now this activity is more of a thought experiment. Imagine I gave you the code that will read in all the words from, I don't know, what's a popular book these days? I don't know. Someone yell out the name of a book. Harry Potter, fantastic. Still very popular. So I gave you the code to read in all, the whole entire text of Harry Potter. And I ask you the question, how many unique words are there in Harry Potter? Well, that suddenly becomes very easy to answer if you use a set. Take every single word, iterate over the collection of words, and add each to the set. If there's a duplicate, well, it basically ignores it. At the end, then I can ask, well, what's the size of the set? Boom, done. And then I can ask more complex questions. Like, what do I have here? I gave you another book and asked you, which words do they have in common? Well, that's just the intersection of those two things. What's in one but not the other? Well, that's the difference. So sets can be very useful in a practical setting. Cool. The bad news, so in many programming languages, so Python's a little different. I know that's been kind of a theme throughout the whole semester. In a lot of programming languages, sets are free, like they are in Python. And when I say free, it's not even a good word to describe what I mean. In Python, the moment you load up Python, you got sets. There they are. If you want to use them, you can use them. Just like lists. If you want to use them, you can use them. Dictionaries. If you want to use them, you can use them. But in a lot of other programming languages, it's not that simple. In a lot of other programming languages, you got to write what these things mean. Now, actually, we're really lucky because in a lot of other programming languages, we can just import these things. Someone somewhere already wrote them, but we have to explicitly import these things. But in Python, it's great, it's easy. It makes our life really easy because you get it for free once you start opening up Python. The good news doesn't really matter. The bad, okay, what am I saying here? Dictionaries, tuples, it doesn't really matter first right now as long as we don't really know. So, okay, the good news is at this stage, I'm throwing a lot of high-level stuff up at you. Lists, they're fantastic, powerful data structures. Dictionaries are also fantastic, powerful data structures, and same with sets, same with tuples. There's all these things. You know how to use them, but you don't know what's under the hood. You don't know, well, how exactly does this work? What I mean is, if I asked you, okay, with a list, go implement sets or something. Well, you don't know how to do that right now, do you? You might be able to figure it out, but it's not like obvious at this stage. So right now, it's like the analogy of you know how to drive a car. You don't need to know how all the inner bits of a car work in order to drive that car. You don't need to know the timing of your internal combustion engine to drive your car. It doesn't matter. You can use these things, these tools, to do what you need them to do. That's fantastic. And for a lot of people in here who are not going to continue, like with 162 and whatnot, that's fine. Look, you'll by the end of the semester, you will have learned a lot. Hopefully at the end of the semester, you'll look back and go like, oh my gosh, what the heck? We learned everything. You do learn a lot. And hopefully you'll be able to use what you learn for the stuff you're interested in. Maybe your degrees, another class, I don't know. But sometimes we do have that curiosity and we wonder, wait, what is actually going on under the hood? I want to know how that internal combustion engine works. Well, we will start to cover those ideas in like 162. And then next year, and so on. We start to learn more and more and more. At this stage, it's still fairly high level. And you can use these things. Make use of what they're good at to solve your problems. That's awesome. But eventually, we're going to start to wonder, how do all these things work under the hood? Okay, debugging. Who here's had to debug their code? Everybody, of course. Well, I guarantee, I know that each and every one of you has kind of come up with their own system or mechanisms for dealing with debugging. You know, it's not working, well, you try some stuff, you change it, whatever. You figure things out. You've got some sort of system that you use when you debug. We'll talk about some ideas people do for debugging. Most of these things are going to be intuitive, things you may have already done, or things you know you should do but you haven't done. But debugging, as you may have noticed by now, most of the time when you're programming, it's like 99% debugging, right? Like the majority of the time you spend working on the assignments isn't writing the code that's correct, it's fixing the code that's not correct. I know it sounds ridiculous, but that's what it is. That's what a lot of programming is. So let's talk about some strategies for debugging. Okay, debugging, blah, 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 blah. Usually when you ask someone who's been like a programmer or software engineer for a little while, and you say like, what skill do you wish you learned a little bit more of during your computer science degree or whatever? And I shouldn't say that, but many, many times they're like, I wish I learned how to debug better. Because they go on to discover that, yeah, that's mostly what my job is. Okay, there are some errors that are perhaps easier to fix. Things like syntax errors. There are things that like, okay, you hit run, and Python goes, no. Something's wrong with this code, I don't know what I'm going to do. It won't even start running. So like if we look at that, fix this Python function, take a second look at it, and let me know, like, identify all the bugs with this code. See if you can count them. See how many bugs you can find, syntax errors you can find in this code, and we'll point them out. Who wants to say how many they found? No one. Oh, no. What do you say?
I thought I saw 4 or 5.
4 or 5. Okay, well, what are they?
Well, def with 2 F's.
Ah, yeah, that's not a thing. Okay.
Yeah, backwards bracket.
Backwards parenthesis, yeah.
A equals A.
A equals, what's wrong with A equals A?
Like you haven't defined, like you're defining A as itself in the thing.
Well, yeah, that's not a syntax error. We can do that actually.
Oh, okay.
Because A is a parameter, so it does exist.
Oh, right, yeah, sorry, yeah.
Yeah, okay. Well, keep going.
And, oh yeah, plus times 3.
Plus times 3, yeah, I don't think that's a thing. Anything else?
I think that's all.
What do you see?
That's for those.
Broken is misspelled at the very top line.
That's true, but it's not a syntax error, but you're absolutely right.
I just thought whatever it printed out after that it would have something to do.
Oh, you're absolutely right. 100% right. I missed that one. Look at that. Bug slipped by everybody. I'm calling the function broken, but it doesn't exist because it's borken. Yeah. What else? What do you say at the back?
You're missing the colon.
We are missing the colon. What else? Now, the last one I see isn't, I don't think it's a syntax error. I think the program will run, but it's definitely not good. What do you say?
Walrus, just there.
Walrus is just there. It'll give us an error because it might not be defined, but maybe somewhere above it was defined out. But walrus is kind of useless, isn't it? So there we go. Looks like there's 6. Because I counted 5, but yeah, I missed the whole broken thing. Because it's not called broken, it's borken. There's also things like type errors. These are errors that, again, might be a little easier to debug. Some of them might be like floating point precision issues, which aren't necessarily errors, but they can cause errors. But also, if I try to add 2.03 plus octopus, I mean, that doesn't make any sense to anybody, let alone the computer. Like, if I tell you what's 2.03 plus octopus, you're going to look at me like I'm crazy. That's not a valid question you can ask when Python's saying that. So that's like an issue with using things and the types and whatnot. Other programming languages make it a little easier to avoid type errors, because in other programming languages, when you create a variable, you have to say, this is a variable that's an integer. And it can only ever be an integer, but you know how in Python we can be like a equals 5, a equals the string hello, and Python's cool with that. Other languages, if you want to make a variable a that holds on to 5, you have to say integer 5 equals a. And then even before we hit run, Python, or the programming language can be like you're trying to add an integer and a string, that's not a thing, because it knows what the types are before we hit run. So here's the thing. Here's an example. If I have this code right here. Whoa, what's going on? I've angered it. Depending on the types I give this function, it's going to give me a different answer, right? No big deal, I suppose. But, like, maybe we could take advantage of this fact. Maybe this is really what we wanted. We wanted this function to play double duty. Great, fine, it's doing its thing. But, I mean, I'm certain you can imagine a world where this function should only ever add integers together. Or maybe it should only ever concatenate, concat's probably for concatenate. Maybe this function should only ever take strings. So maybe if that's what you're thinking, then when you give it 2 integers and it returns 10, it's kind of doing improper, not really what you wanted functionality. That's a problem. Python lets you do this, and this might be dangerous. But a moment ago when I was saying other programming languages, you have to be explicit about what all the types are. So in another programming language, I'll show you kind of what the syntax might look like. There. This, of course, isn't a thing in Python. But in other programming languages, if I had 2 parameters, I could tell the function, you're going to take 2 parameters and they're both strings. That way, if someone comes along and tries to give it integer 5s, the programming language goes, no, 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 you're misusing this function. So it kind of helps you debug your code. Any questions about that? Yes.
Is there a way to do that in Python?
There's a way to like assert things, yeah, but let's not worry about that right now. And I believe it got better in Python 3 over Python 2. Like it made it a little easier to do that, but I don't remember. So when I talk about like simple errors, that's not really a good name for them because simple might imply like, oh, trivial to fix. That's not really the case. But these are errors that like, oh, okay, syntax, and it kind of shows you where it is, and maybe Python helps you a little bit pointing out where the bugs are. But more difficult errors to debug are logic errors. These are errors that Python's running, it's following all the instructions you set, and you're expecting it to do this, but it did that. And that's not good. So for example, for those of you in the lab yesterday, and those of you that will be doing the lab today, you will very much discover, and for those of you that have been working on Setup World in Assignment 3, you will quickly discover perhaps that issue of like lists of lists. You know what it's supposed to do, but it's not working that way. That's a logic error. And those are a little harder to work out. So what are the strategies? What are the coping mechanisms we use as programmers to address these situations? Well, here is tried and true, easy to use. Probably my favorite method is throw print statements everywhere. What's the value of that variable? I don't know, print it out. Have like 1 billion print statements, and they'll help you debug. If you go back and look at my undergraduate code, it's full of commented out print statements. With questions like, okay, what's this value? And things like, did I ever get here? So if I hit run, let's say I had an if statement. And I'm like, okay, it should be going inside that if statement. When I hit run, and I put a print inside that if statement for debugging purposes that says, ooh, did I ever get here? And I hit run and I don't see it, then I know, ooh, there's an issue with that if statement. Or at least it's above that if statement. Maybe the values aren't set right. I don't know. So you can use these if statements to kind of narrow down and focus on maybe where your error is. Error. This is my go-to strategy. I use this all the time. Why? Because it's easy. It's easy, and it can work pretty well if you know what you're doing. Yeah. Also, if you go back and look at my code from undergrad, I have a lot of commented out print statements that look a lot like that, except maybe even more explicit. I don't know. So be careful. I don't really care, but maybe a TA that's marking it gets offended. I don't know. But I don't know. Maybe that's helpful. Maybe that's your coping mechanism. Cursing in your comments or in your prints. Great. Now, because we are getting tight on time, what I'll do is I will come back here. Actually, I think next lab does this. I'll double check. But I'll quickly talk about other ones. Pencil, paper, or even better, a whiteboard. One of the best investments I ever made as an undergrad, I got it in second year, was I went to Walmart or something and bought myself a whiteboard. Because I felt I was using too many pieces of paper and I was wasting them. So I grabbed a whiteboard and used the dry erase markers like this. And I would write out what's happening. Okay, on this line of code, this is what's happening. On this line of code, this is what's happening. On this line of code, this is what's happening. Oh, wait, no, that's not what's happening. Okay, so here's the issue. This right here might be one of the better strategies for debugging. But people don't want to do it because it feels like a pain in the ass. I know that when you're doing it, you're like, no, I can fix this. I don't need to resort to this. You know what? Do yourself a favor and just start writing it down on a piece of paper and a pencil. We're getting to the stage where our code is getting too complex to just figure it out without keeping track of your ideas. This is a really good strategy. Writing it down, keeping track of all the values. What is it? What should it be? Maybe combine this with printing out values. Another one, here's a good one. This isn't a joke. It's called rubber duck debugging. If you don't believe me, there's even a Wikipedia article on it. See, it's a real thing. Here's the idea. Explain your code out loud. And because it feels ridiculous to do that, by just talking to yourself, get some inanimate object that you talk to so it feels marginally less absurd. I'm not joking. This is a remarkably popular strategy that works. Because sometimes you look at your code, it makes sense. But when you slow down and you articulate, you say okay, on this line of code, what I'm doing is I'm adding this value to that value, and then I'm dividing it by 2. And then on the next, I'm checking if that value is less than, it's supposed to be if it's greater than. When you start saying it and articulating it at a slow pace, when you're speaking, you have to say it slower than your brain's going when you're looking at the code. But this right here, remarkably effective. It's very popular. Delta debugging. This right here is another really common strategy that works really well for me. You wrote your function, you hit run, it's not quite working the way it is. So here's what you do. Comment everything out. Comment it all out, hit run. Should work because there's no code. Then add like one line at a time. Hit run. Did it do what it was supposed to do? Throw a couple prints in there. Combine this with that printing one. Are the values what you think? Yes, no. Okay, uncomment that next line. Okay, do it again. One thing you will know, you've experienced this before. When you're looking at your code, make no assumption ever about what each line does. Far too often I catch myself going like, okay, on this line of code it does that, and then I know the next 3 lines of code do that, but that was a bad assumption. I assume I can skip, okay, I know what those 3 lines do. No! What does the line of code actually say? Remember, the trick to programming, the trick to understanding code is, what does it say? Programming tends to be very explicit with what it says it's doing. It has to be, just by how it works. So if you slow down, make no assumptions, and look at what does the code I have say, versus what is it supposed to do? Don't make those assumptions. You will waste your time. People look for that silver bullet. What's the trick? Slow down. Make no assumptions. Delta debugging. Articulate it to a rubber duck. Talk to anyone who will listen. Tell your mom. Maybe she has no idea what the heck you're talking about, but it doesn't matter. Just have someone listen to you. So many times you talk. I have so many times. During my PhD, I'd sit down and tell a friend, like, okay, look, I'm having a hard time. Listen, let me explain this to you to make sure I'm not crazy. And I start talking. The other person doesn't have to say anything. They just sit there. And the next thing you know, I go like, okay, well, that's there's the problem. Nice and slow. Nice and slow. I'll give you another example of why you should never make a single assumption. One time, I wrote a for loop. Well, it was a for loop in a different language, but whatever. I wrote a for loop. And I called that for loop. I started it at this. I wrote this code. I said like, for I equals 1. Okay? Just that's syntax for another language, where I starts at 1 and goes to another value. Great. But the mistake I made, I don't know how I made this mistake, but the mistake I made was, that was actually an L. I wrote an L. And I couldn't tell the difference because I was like, oh, that's just a for loop, blah, blah, blah. I didn't take the time to look at the L. And I spent so long this was during like my third year, and I had like 40 other students look at the code, and we were all going, this doesn't make any sense. Why is it not working? I don't understand. And then finally I discovered this ridiculous, stupid little error. Just because the L and the 1s look so similar. Anyways, have a great weekend.